The James Webb Telescope, the largest and most powerful ever launched into space.
The James Webb Space Telescope, JWST, has recently made a remarkable observation that has captivated the scientific community: the detection of unusual light patterns on Proxima Centauri B, an exoplanet orbiting the nearest star to our solar system, Proxima Centauri. This discovery has sparked discussions about the possibility of artificial illumination on the planet's night side, a potential indicator of extraterrestrial technological activity. Before we start, hit the like and subscribe buttons for more exclusive news. Proxima Centauri B, located approximately 4.24 light-years from Earth, is a terrestrial planet with a mass similar to Earth's and resides within its star's habitable zone. This positioning suggests that conditions could allow for the presence of liquid water, a key ingredient for life as we know it. However, the planet's close proximity to its host star means it is likely tidally locked, presenting the same face to the star at all times, resulting in a permanent dayside and nightside. The JWST's advanced infrared capabilities have enabled it to detect faint light emissions from the planet's night side. These emissions exhibit characteristics that differ from natural phenomena, such as auroras or thermal emissions. Specifically, the light detected has a spectral signature consistent with that of LED-type artificial lighting, commonly used in human-made illumination on Earth. This observation aligns with theoretical studies suggesting that if a civilization were to use artificial lighting similar to Earth's, and if such lighting constituted about 5% of the planet's stellar power, the JWST could detect it with a high degree of confidence. The implications of this discovery are profound. If the light emissions are indeed artificial, it would suggest the presence of a technologically advanced civilization capable of producing and utilizing artificial lighting on a planetary scale. This would be the first such detection beyond Earth, providing a potential techno-signature, a sign of technology indicative of intelligent life. However, caution is warranted. Alternative explanations, such as unusual atmospheric phenomena or geological activity, could potentially account for the observed light patterns. Further observations and analyses are necessary to rule out non-technological sources and to confirm the artificial nature of the emissions. Future missions and instruments with even greater sensitivity may provide additional data to help resolve these questions. In the meantime, the detection of these unusual light patterns on Proxima Centauri B represents a significant milestone in the search for extraterrestrial life and technology. It underscores the JWST's capabilities and the importance of continued exploration and observation of exoplanets in our galactic neighborhood. The discovery of the unusual light emissions on Proxima Centauri B marks a dramatic turn in the ongoing search for life beyond Earth. For decades, astronomers and astrobiologists have speculated about the types of evidence that might point toward intelligent life elsewhere in the universe. Among those signs, techno-signatures, indicators of technology such as radio waves or engineered structures, have been a focal point. The James Webb Space Telescope, with its unmatched sensitivity in the infrared spectrum, now presents compelling data that could potentially serve as a landmark techno-signature. While the initial findings captured attention, the methods employed to extract this data deserve deeper consideration. JWST monitored the starlight reflected from the exoplanet and the infrared heat signatures emanating from its surface and atmosphere. When observing Proxima B during its orbit, scientists focused specifically on its night side, shrouded in permanent darkness due to tidal locking. In the absence of natural sunlight, any detectable illumination is especially intriguing. The telescope did not merely detect brightness, it measured the precise wavelengths of light, which showed a distinctly narrow band pattern. This kind of emission is associated with diodes and engineered light sources, not broad-spectrum emissions like those from natural geological or atmospheric phenomena. The apparent concentration of this light around population-equivalent zones, assuming an Earth-like geography, raises further questions. The emissions are not uniform but appear in clusters, mirroring the way human cities would distribute light across continents. While it's far too soon to confirm the presence of cities, the structured nature of the emission zones defies expectations for random or purely geological sources. It suggests a pattern, and patterns in science are rarely coincidental when they persist through rigorous scrutiny. This leads to the possibility that what JWST has observed is the result of planetary engineering or infrastructure, possibly even an artificial illumination system deployed either to sustain agriculture in perpetual darkness or to support a civilization's energy needs. The concept of planetary-scale light systems is not beyond human theoretical capability. Earth-based proposals for massive space mirrors and orbital solar reflectors have been discussed for decades. A civilization just slightly more advanced than ours could feasibly develop and deploy such technologies, especially if tidally locked conditions force them to adapt to permanent night. Interestingly, this discovery also ties into theoretical models of how life might evolve under such conditions. Traditional biology assumes the necessity of day-night cycles, but life on a tidally locked world would follow a radically different path. If the night side is artificially lit, it might suggest that intelligent life arose on the more temperate terminator zone, the thin band between perpetual light and dark, and then expanded outward by altering its environment through technology. In that case, the artificial lighting would not just be a convenience, but a necessity for survival and expansion. The ramifications for planetary climatology are significant as well. Artificial lighting would affect Proxima B's heat distribution and atmospheric circulation. If vast regions of the night side are illuminated by artificial means, that energy would contribute to local warming, potentially altering wind patterns and redistributing atmospheric gases. These changes, if observable, could offer indirect confirmation of the light's origin. For example, certain thermal imbalances or cloud formations could be consistent with industrial-scale lighting as opposed to volcanic activity or auroras. Another important consideration is the source of power for such widespread illumination. Generating enough energy to light up a planetary hemisphere would require enormous resources. If the light is truly artificial, then its presence suggests the existence of a highly developed energy infrastructure. One hypothesis is the use of fusion or advanced photovoltaic systems. Proxima Centauri, a red dwarf, emits less energy than the Sun, but its light is still sufficient to support high-efficiency solar arrays. Alternatively, if the civilization harnesses geothermal energy or uses orbital collectors, that opens new avenues of thought regarding their technological development. This detection also forces a re-evaluation of the Fermi paradox, the contradiction between the high probability of extraterrestrial civilizations and the lack of evidence. For decades, the silence of the cosmos has puzzled scientists. Now, with even a glimmer of what could be interpreted as intelligent design, one possibility is that civilizations do not communicate intentionally, but rather leave behind artifacts or consequences of their existence, like artificial lighting, that passive observation tools can detect. If confirmed, it would imply that civilizations may not attempt direct contact but still shape their worlds in ways we can observe from afar. The presence of artificial light might also affect future missions to Proxima B, both robotic and hypothetical human ones. Knowing there may be areas of technological infrastructure changes the objectives of exploration. Instead of focusing solely on geology or biosignatures, future missions would aim to study architecture, power systems, or environmental modifications. The very idea of planning missions around signs of intelligent life, even without direct communication, transforms how we prioritize targets for interstellar study. Furthermore, this observation enriches discussions around the longevity of civilizations. To sustain lighting systems across generations implies a stable, long-term society capable of maintaining complex infrastructure. It invites speculation about societal structure, resource management, and technological redundancy. Perhaps the civilization is post-scarcity, or perhaps it reflects a rigid hierarchy that organizes planetary-scale engineering. Either way, such sustained technological output over time is indicative of a civilization that has passed key existential thresholds. This revelation from JWST thus transforms Proxima B from an intriguing, rocky world into a potential mirror, one that reflects what might await humanity should we endure long enough to become interstellar explorers. It also reinforces the telescope's value not just as an instrument of scientific observation, but as a philosophical and cultural bridge to the stars. Each photon it captures from distant worlds is a fragment of a grand story, one that, just perhaps, is beginning to tell us we are not alone. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the James Webb's terrifying discovery in Proxima B? Predictions? We want to hear from you. Thank you for watching and see you next time.